Mhm. Let's stop that. As always, if somebody is, somebody say that again for the recording. Let me kind of back up. So there will be a quiz on next Wednesday. That was the 22nd, I think, on the last part of chapter 6. I'm thinking about doing some cumulative review quizzes, just so that we're more ready for the final. The final itself, there was a question about that just a second ago. It's gonna be, we'll log in to Zoom at the normal time for our final exam on that day, the day that it's scheduled for. I don't know, it's on this homework sheet. And then I'll make it active on Canvas and you go get it and start working on it. If somebody has an issue, just like the normal final, if somebody has something happen, if somebody has an issue, I'll work with that person. We'll schedule a time for a makeup, right? Or like a, whatever you call it. Is everybody with me so far? Everybody, any questions on that?
Yes.
Yes.
I'm with you.
Oh, okay. I thought, I thought you had a question. All right. Okay. Anything else, guys, before we get back into where we were? Anybody else have any questions from homework stuff that you're all working on? I'm hoping this weekend maybe I can catch up. I mean, we've been having meetings even on the weekends. So I'm on the committee that, I'm actually the chair of the committee that approves new courses, and we are working on what courses we can actually run in the summer and the fall, what the summer schedule is going to look like given the situation. We're pretty sure we're still not going to be able to be back on campus. You don't have to know all that, I'm sorry. So it's just a lot going on. So that's why I feel like I've fallen behind a bit in keeping up with grading stuff. Okay, anything else before we get back into where we left off? So if you do look on Canvas, there's a section 6.5 and 6.6 page, and there's a divide polynomials handout. Let me pull it back up here again. All right, come on, you can do it. There you go, computer. Are you guys seeing it now? I already have it open. Stop, cancel. Over here, this guy. Right, so these first few, how would you do this first one right here? Anybody have a suggestion on how to do that first one? Right here, is everybody able to see that? 8k to the 5th?
Divide each by 2.
Yeah, you rewrite it into 3 little pieces. 8k to the 5th over 2k minus 4k cubed over 2k plus 4k squared over 2k, and then you reduce each piece. Exactly. That's
like we divide every number in a top with a 2k. Okay.
Yep, because that's what it says. It says that whole thing on the top is being divided by 2k. So each piece has to be divided by 2k because that's what it says. So then we do that.
Excuse me? Can
Yes.
we add the k fifth the same?
Say again?
The k fifth?
K fifth? What about it?
We put on the same?
All right, let's try this one out. So I'm going to stop sharing so you can see my board better. Does everybody write that problem down if you don't already have the sheet up on your screen or print it out? So write that problem there down. And let's try it out. This first problem. All right, and I'll write it up on the board too. So, okay. Let me see if I can't highlight mine. Okay. Oh, let me take Bob and Linda away. Sorry. I don't know if any of you guys watched that show. Okay. All right. Where's all my other markers? There you are. Okay. So here's the problem. Minus 4k cubed. All over, what was it, 2k? 2k.
Yes.
So the first step is to do exactly what it says to do. It says all that stuff on the top, man, my hair is really crazy. all that stuff on the top gets divided by 2k. So that's exactly how we rewrite it. We kind of make it into 3 smaller problems. So we rewrite this as 8k to the 5th over 2k minus 4k cubed over 2k plus 4k squared over 2k. And then we just reduce each one of those. That's how all 3 of those work. This one happens to be nice because nothing's left on the bottom anywhere here. You guys see that?
Yes.
Nowhere does the bottom have more k's or more 2's than the top does. So all the bottoms are going to cancel. There could be another one later where there's more k's or m's or b's or whatever on the bottom. So when you reduce it, there's going to be more left on the bottom. So what do you get here? Well, this is 4. K to the what?
6k?
4.
So I really get into what this means, right? K to the 5th means multiply k 5 times. And then I'm dividing by a k. So I am losing a k. That's why when I divide, I subtract powers. That is why that rule is the way it is. Always go back to why the rule makes sense. Don't just memorize rules.
Okay.
You've got to know why the rules make sense. So 1k would cancel, so I'm left with 4 of them. 4 divided by 2 is 2. K cubed divided by k squared, see? And then, of course, plus 2. K squared divided by k, I lose a k, so I have 1k left. Okay? So don't let, dividing by a one-term thing is relatively easy. You just break them up. In this case, 1, 2, 3 parts because it was a trinomial divided by that. However many parts there are up here, that's how many parts you break it up into. And then reduce each piece. It's when the bottom is not a monomial. That's when things get sucky, right? Like we saw last time. All right. So any question on those kind of problems? That's section 6.5. Section 6.6 is where we start doing long division of polynomials, which I know it sounds like math people got around and said, how can we really make students just hate what we do? But I mean, this is important. This is actually, everything I teach you has got a purpose, believe it or not. Like, I don't believe you, Jeff. All right, that's fine. So let's do this again. All right. So it just takes a couple of times, hopefully, to get it in the brain. I've got the, if you got the handout from Canvas in front of you, you've got the example, right? And let's do this. Let's redo the example that's on the handout. So let's do this one. Let's see. So let's redo this. This is on the handout. This is worked out on the handout. It's on the Pages section in Canvas. So the first step when you're doing this division is actually the same first step if it was just numbers. 2x times what is 2x squared? Another way to think about that is, what is 2x missing?
1.
Yeah. What is 2x missing to be x squared? It's missing an x. Does everybody see that? 2x has got 1 nx in it. 2x squared has got 2 x's in it. So 2x needs an x. So 2x times x is 2x squared. Oh, let me let this person in. All right, let me stop for a minute. I put that in a different place than where the book puts it. So if you look at the book, they move that over a place. But to me, this actually makes more sense. And it doesn't really change anything, to be honest. So then I go, x times 2x is, of course, 2x squared. Hopefully some of you guys are like, well, yeah, we knew that shit. That's why we put x there. It's always going to be that. That's where the x came from, is what makes it that. X times 2x is 2x squared. X times -1 negative x, but then what do I do before I put those together? Same thing we do every night, Pinky. No, same thing we do with if it's just numbers. What do I do on this step? So if I had to do this,
Change sign. Change sign.
yeah, you got to subtract, right? When you do long division, don't you subtract right now? You would subtract, and that would be change the signs. That's what subtraction does. Right? Sound like I'm drunk. Subtraction just change the signs. So then 2x squared minus 2x squared cancels. 5x plus x is 6x, and then you can bring down the minus 1. Let me stop for a minute. Who's got? Let me mute everybody. Okay. So make sure you can really follow where everything I've written has come from. That's there because 2x needs x to be 2x squared. Once I write that, I then multiply it to get what goes here, and then I change the signs. That's the step where I subtract in division. That's what subtraction means, change the sign. Put those together, bring down the minus 1, just like I would do with normal numbers. Savannah, what you got?
Can I just put it separately? Like, I know we have to learn long division, but it's really hard to understand. Like, can I put the 2x minus 1? Oh my gosh, I don't know. Can I separate it like the other equations? You know?
I don't know.
Like, do I have to do it long division? Like, can I put that?
Oh, that's a beautiful question. Thank you. Let's finish this, and then I'll show you why. I show you why we have to do this. The other way will not work worth shit. So I love Savannah's question. Savannah's question is basically, why the shit are we doing this? The other thing we just did was easier. What's wrong with you, Jeff? Smack. The other thing was easier because the bottom was just one term. But you're right. I never really got into why we have to do this. So I will do that. Thank you, Savannah. Okay. Let's finish this up, and then I'll show you with this example why doing it the other way does not work at all. Nowhere near. Oh, shit. Okay. So now I've got this here. 2x times what is 6x?
3.
3. So I'm going to put a plus 3. 3 times 2x is 6x. 3 times negative 1 is negative 3. And then what do I do? What do I do?
Subtract.
Yes, so change the signs.
Sign.
I like it. Uh-oh. All right. Negative 1 plus 3. So these cancel. Negative 1 plus 3 is 2. Plus, yes.
2.
Oh. And then I can write that as plus 2 over 2x minus 1. All right, and that's in the that's on the handout. That's the example that's on there. So let me go back to whose question was that? Savannah? Was that your question?
Yeah, that was my question.
All right. Here we go. Here we go. So we got this. Everybody's got that. It's on the sheet. All right. So let me write this. This is what this would have looked like before I wrote it in long division form. Right. This is the problem we just did. What was this? 2x, no, just 2x minus 1. Now watch. Now watch. This is kind of neat. So I love the question. If I were to break this up, it would be 2x squared over 2x minus 1, right? Plus 5x over 2x minus 1, minus 1 over 2x minus 1. Let me stop right there. Is that all right? That is how it would work. Doing the other way, right? Okay, maybe. And then you cannot do anything. Why can't I cancel those 2's? Does anyone know? I cannot cancel those 2's or those x's. Why? Because you're not trying hard enough, Jeff. No. Come on, you guys can do it. Why can I, what can I do here? What can I do there? I can kill the 2's, right?
You can't cancel it because there's 1.
Not because there's 1, because there is subtraction, right? Does division cancel parts of subtraction? No. No, you guys with? So watch. Can you reduce 4/5? Can you reduce 4/5?
No.
Nope. Even though I can write, can't I write 5 as 4 plus 1? So then I can kill the 4's, right? But you just told me I can't reduce it. I shouldn't be able to reduce it if I just write it differently. It's still the same number, isn't it? So why can't I just kill those 4's? Because division is not the opposite of addition. Division is also not the opposite of subtraction. Do you guys see that? You know I can't reduce 4/5, right? Can I reduce 4/8? Yes.
Yes.
Why? Because 8 is 4 times 2. And then
Yes.
division kills that multiplication. Do you see that? Whenever you want to cancel something, the operations present better be opposites. Because that's how you cancel stuff. So here, division, subtraction, ain't the opposite. Oh, shit. All right. So, I mean, I really hope I'm not coming off as condescending. I just want you guys to see, we actually know this. We know that I can't reduce this. So that's exactly the same problem. It's the same thing, right? Variables are just numbers I don't know. They can't do anything numbers can't do. Okay. What was the other thing I wanted to say? Oh, yeah. Somebody kind of got that idea. I mean, it's not a bad, Savannah, I love it. You always want to say, is there an easier way than the shit we're doing right now? But sometimes the answer is no, right? As a student, I always try to find the quickest way to do stuff. Kayla, what's up?
Can we do another long division problem? I'm still a little confused in the beginning.
Yes, we can. We'll do it right now. Actually, after I do one more thing, I'm going to take this away. Now, I do want to show you something. Let's see if you guys are cool with what's about to happen. Steps change sign makes me confused. I'm not sure what that means. Oh, I see what you mean. Okay, I'm with you. Can I cancel anything there? Oh, step change. I'm still not sure what you're really saying, Asha. When we do the next example,
Okay,
tell me when
it's
we do
okay.
the step. I think I know what you're talking about, but I'm not really sure.
Mhm.
Anybody, can we cancel anything here? Let me ask you this. Let me ask you. Sorry. Yes, we can. Let me ask you this. What's on the top? What are the parts of the top? I get it started. There's a 4.
Parentheses.
And there's a 2x minus 1, right? It is 4 times 2x minus 1. Now watch, you ready? Here's where Jeff gets like he's crazy again. There ain't no 2x in that whole thing. There's no 2x in that whole damn thing. There's a 2x minus 1. Do you guys see what I'm saying? No? So whatever number this is, how is it related to this number?
Same.
Same. So this is 4 times a number divided by the number. I can cancel that whole damn thing. The answer is 4. Why? Because division is the opposite of multiplication. So division can kill that multiplication that's happening all day long. All day long. Did I kill a part of a subtraction problem? No. I canceled that number with itself. Right? So this is the same thing as 4 times 5 over 5. 4 times 7 over 7. Do you guys see that? Number, same number. Number, same number. Number, same number. And what happens in each of these? Those cancel, you get 4. Those cancel, you get 4. Okay, maybe. Okay, that's enough of that, Jeff. I think I've. So I don't want you to lose always wanting to find the easiest way to do something. There's really nothing wrong with that intention, or else my whole life is shit, because that's what I've always tried to do with every problem I've ever gotten. But at the same time, you want to appreciate the longer way to do some things, because maybe it helps you with more complicated stuff. So you want to, there's a balance there. Anyway, so let's do another example. Let me see. It's a great time to have, I think I'm getting a cold. What a great time for a cold. You got cold? No, it's cold. Cold, not cold. Cold. All right. So what if I had, let's see. Is there a glare? You guys all right? Yeah, you guys are right. Let me see. What you got, Jeff? Sure, I like it. Davy. Don't know where that came from. Davy Crockett. All right, so, and again, I just desperately, and again, if you haven't done this for yourself, I suggest that if you've really forgotten how to do long division of numbers, you have to focus on that first. You have to do a few examples, look up a few videos maybe, if it's been forever. I understand. You do it and then you get calculators and you say, screw that shit. I understand that. But it's a skill we still need. So again, some of you guys might be sick of this, and I apparently don't care. So if I had this, what am I going to put up there? If I had this problem, what am I going to put up here? Where am I going to start? What are you going to think to yourself? Are you going to work with 71? Sorry, yeah. Because I'm going to look at 7 and 56. I'm not going to look at 71 and 569. I'm sorry. I don't have the 71's times tables memorized. If you thought I did, too bad. So yeah, of course I'm going to do 7 into 56. So I'm going to put an 8, and then I'm going to go, okay, it's not really, it's a 71. So now it's 8 times 71, 568, change the sign, combine, put that over that. Okay, so every step I just did is the same step we're about to do up here. So I don't look at 71, I look at 7 into 56. So I don't look at x plus 7, I look at x into x squared. X times what is x squared?
Another x.
X.
Yeah, right? X times x is x squared. So x times x is x squared, like we just said. X times 7 is 7x. And then what do I do? It's been a long day already, man. It's crazy. What do I do now? What did I do here?
And subtract.
Yes. Now, is this the part you have trouble with, Youngsha?
Yes.
So I subtract this. That's what I have to do. Did I subtract a part of this number? No, I subtracted the whole damn number, right? I subtracted all of 5 to 68. So whatever this number is, I got to subtract all of it. And when I distribute the negative, that's why I say, why even put the parentheses in? Just change every sign. Uh-oh. I gotta watch my mouth now. It's a little one. So x squared minus x squared cancels. 3x minus 7x, negative 4x. Bring down the negative 29. X times what is negative 4x?
Negative 4.
Yeah. X times negative 4 would be negative 4x. Negative 4 times x is negative 4x. Negative 4 times 7 is negative 28. And then I
Subtract the new I.
change the signs. These cancel like they always should. Negative 29 plus 28 is negative 1 minus 1 over that. Really the same thing we did down there. Okay. Anything else about those? We'll do another one, I think, with like a missing term. See what you guys think. Oh, somebody's got a thumbs up. Thank you so much. Like and subscribe. I'm joking. Let me see. Okay. We're going to do another one. It's got a little bit of a difference to it. So let's say I have this problem. See if you guys can identify. I kind of laid the groundwork for this yesterday. So there's actually a purpose beyond the immediate thing I was talking about. There's something about polynomials not being able to show zeros like numbers can, or we don't need to show them, right? So if I write 11 versus 101, those are obviously two very different numbers, right? If 101 people come and I only got 11 chairs, I'm going to be in trouble. So I'm like, why didn't somebody write the damn zero? But if I write x squared plus 0x minus 7 and x squared minus 7, are those two different things? No. Those are the same thing. 0x is 0 and 0 minus 7 is minus. It doesn't need to show up then. So it's just the way that we have to represent them doesn't require the 0 because they're not place values. It doesn't matter which one's first or second. It doesn't change if it means hundreds or tens. But watch, so the problem here is if I am missing a term, I need to write 0 of those when I do long division. I need a placeholder. So here's what I mean. This is what this is going to look like. I'll do x plus 3 into x cubed plus no x squares plus 5x minus 2. Did I just change the top? Is it different what I wrote down? No. It's the same thing because 0x squared is 0. I like that. Oh, okay. No, okay. All right. And you'll see very quickly why I need to do this. So somebody help me out. First step, x times what is x cubed? How many more x's do I need?
X squared.
X squared, yeah. So then I write x squared. X squared times x is x cubed, like I knew it should be. Get Jeff. There you go, buddy. What's x squared times 3?
6.
No, what's x squared times 3?
3x squared.
3x squared. 2x times 3 is 6x. X squared times 3 is 3x squared, right? So if I did not put that there, I'd have nowhere to put my x squared terms. You guys see that? That's why I have to put it, if it's missing, I have to put 0 of those things. So now 3x squared, I have a place to put it. You guys appreciate that now, maybe, or you're like, I don't appreciate none of this shit yet. Okay. And then, of course, to continue, I change the signs.
I don't understand how you got this number.
Wait. Okay.
X squared,
What's going on?
please.
Which number?
No, I know the x squared times 3. We got 3x squared. How?
What's y times 3?
It's y 3. Why?
Better than that. How do we write it?
I confuse. I don't know.
No. Just how do we write it? We always write the number in front. That's all. What's y times 3? 3y.
3y. Okay.
What's a times 3?
3a.
What's m
Yeah.
times 3?
Okay, 3m. I got it.
What's x squared times 3?
Oh, 3x squared. Okay.
Make it like, so again, the power can't change unless there's another x with a power. The coefficient won't change unless there's another coefficient. Do you see that?
I got it.
Yeah, okay.
Got it.
So let me catch back up. So
Thank you.
x times x squared is x cubed, and then x squared times 3 is 3x squared. And then I change the signs, like always. X cubed minus x cubed is dead. Die. 0x squared minus 3x squared is negative 3x squared. Now again, if you did not put the 0 there, you'd either make a mistake and somehow combine those two things, or else you'd look at it and go, I don't know what the hell to do. You have to put that placeholder. It's called a placeholder. The x squared place needs a 0. There it is. Just like our number system, we put a 0 if we have none of those things. And then the 5x can come down. X times what is negative 3x squared. I'll need a negative 3 and I'll need another x. See, x times what is negative 3x squared. So negative 3 I need, and I need another x, so negative 3x. So then negative 3x times x is negative 3x squared. Negative 3x times 3 is negative 9x. Let me stop for a minute. And then I change the signs. These cancel. 14x. Bring down the minus 2. How you guys doing out there? Why was this a longer one? Because it effectively has 4 pieces to it, right? So I'm not done yet. I'm sorry.
Yeah, I told you yes.
Okay. So
No.
x times what is 14x?
$14.
14. So if I put a 14 plus 14, 14 times x is 14x. 14 times 3 is 42. Right? I did that too fast, yes. And before I put these together, that's right, kids, change the sign. So then negative 2 minus 42 is negative 44, and I can put that minus 44 over x plus 3, which is exactly what we do if I knew what the numbers were. We do exactly the same thing with the long division. Believe it or not, I know it's hard to believe, but I have to tell you, even if you don't see it, I want you to know that every step we did here is exactly the same step we would do if I knew what the numbers were. They have to be. All right. Do you want to do another one? How we feeling out there?
Yes.
Yes, okay. Any specific one in mind, or can I just make one up, or?
Go ahead.
Make one up.
Yes, ma'am. All right. I would have liked it if you said make one up, math boy. All right, here we go. I'm going to erase this. Jose, why? Here we go. All right. So let's see here. How about let's see. Trying to have something come out kind of nice. All right, it shouldn't be too evil. Let's find out if that's true. So, again, this is the step. I don't know if everybody understands. I look at 3x and I look at 12x squared. And I say to myself, what do I multiply 3x by?
4.
Let me catch up to you. What do I multiply 3x by to get 12x squared? So I definitely need a 4, right? Everybody's cool with that?
Yes.
3 times 4 is 12. And then how many more x's do I need? I got an x. I need
3.
1x.
one more x. I like it. That's all that first step is, which is the same as the first step on numbers.
Okay.
And then you multiply what you just put up here by this whole thing, right? 4x times 3x is 12x squared. 4x times 4 is 16x. And then what do I do before I combine those?
Subtract.
Yeah, and subtract means change the signs.
Okay.
13 minus 16.
3 minus 3.
I like it. And then bring down the minus 9.
Okay.
Now, 3x times
One.
what is negative?
1. I guess 1, right? 1.
I
1
know.
multiply 3.
3x times what is negative 3x?
Negative 1.
One.
Negative 1.
Okay.
Negative 1 times 3x is negative 3x. Negative 1 times 4 is negative 4. And then I
4.
change the signs. I really want you to see, I don't care how long this gets, you keep doing the exact same thing until you go a little crazy. You always want this first piece to cancel or else you have done something wrong, right? See how that piece canceled, that piece is going to cancel. Negative 9 plus 4. So up here I can put minus 5 over 3x plus 4. Oops.
That one is the hard one.
In what way?
It's the exercise, I mean. The 6.6.
Oh. Yeah, yeah. So I don't want you to, I know I keep trying to say it's just the same as numbers, it's just the same as numbers. It looks very different than what we're used to. I'm not saying it's an easy section. I'm trying to say, if you haven't done enough long division with numbers examples for yourself, you're not going to be as connected to what's going on here. All right, so watch this. Let me see.
Okay, I have a question for
Yes.
this one. How I put -1 because you say negative, what is it? The negative 3 minus 3. How we got with the 3? We got which number like? Because we have here negative. Okay,
Yeah.
I got it.
13 minus
I
16
got
is negative 3.
I told you 1, but I don't know how we put the negative 1. Okay, I got it.
Had to be -1, yeah. Okay.
I got it. Thank you.
All right. So here, you guys try this one out. Let me see. Let me put it up here. Let me leave that up there for a minute. You guys try this one out. Oh, I have no idea. Let me see. Yeah. Trying to make it come out not too evil. Yeah, that should come out nice. Yeah, okay. Yes, Curtis, it will be up on the YouTube, on the internets. Okay. Whoa. Holy shit. I get so many emails nowadays. Okay. So I rewrote it up there in the long division format. Take that away. Because the bottom was more than one term, so I have to do long division. X times what is 2x squared?
It's 2.
2?
2x.
2x, I got you. 2x times x is 2x squared. 2x times -2 is -4x. And then I
Minus.
Yep, subtract them so their signs change. These cancel like they should. -7x plus 4x.
-3.
Good. And then bring down the 5. X times what is -3x?
-3.
That's right, -3. Become a 3. All right. -3 times x is -3x. -3 times -2 is +6, but then I
Change the sign.
signs. So these cancel like they're supposed to. 5 minus 6 is -1.
-1.
That's my remainder. So then I can put that like that.
Sometimes confused. Sometimes.
That's good. To be honest, I'm sure when we first started, you were completely confused, along with many other people. How do you know you're starting to get it? You're still confused, but not with as much as you were to begin with, right? That's how it works.
Yes, yes,
That's how it
yes.
always works.
Like you
I
said.
can't, let's see if you'll go with me on this. Let me see if I can make something real quick. Come on, Jeff. 20, if we do 22, no, I don't want to, screw it. So I'll have to think about that. I was going to try to do something cool with this, but I don't want to think about it in my head. I'm too tired. Okay. Let me see. Was I gonna do another one? No. That's enough of those. What? Just to give a little preview for the last section in 6. It's something we've already done, except for one piece. So we've already talked about negative powers. So we all should know what a negative power means. And to be honest, some of you guys used a negative power on the quiz 6. You didn't have to. So there was a problem that looked like this. It wasn't this, but it looked a lot like this. It was the first problem. So the wrong answer is n to the 6th. That doesn't make any sense because there's more n's on the bottom. So how many n's cancel? 3. So how many would be left?
6.
6. Where?
On the bottom.
The bottom.
Yes.
Okay. You didn't have to use any negative powers, but if you did, I didn't take points off because it's still right. Because what's 3 minus 9? What's 3 minus 9?
6.
Try it again. 3 minus 9.
-6.
Negative 6. Thank you. So another way to write that is n to the negative 6. So that kind of proves right there. What does a negative power mean? It means flip. So if I have m to the negative 8, that is 1 over m to the 8th. I flip those 8 m's over. That's all a negative power means. Right? So what is 1 over x to the negative 3? Don't make it harder than it needs to be. Just
-2.
X cube.
-2.
there's no negative 2. No. There's no other x. There's no other power. The power can't be something other than 3. What did I do with this guy? M to the negative 8. What's on the, let's look at this guy again. What's underneath him?
1.
Yes, 1 is under everything, right? Where are those 8 m's at the moment? They're on top. What does a negative power tell it to do? Flip. They all go to the bottom. Now here, where are those 3 x's? In that problem, where are those 3 x's? They're on the bottom, right?
So they need to flip.
So then they just flip to the top. You can write the over 1 if you want to, but you don't need to, right? So watch this. So really what I mean then is, if something's raised to a negative power, wherever it is, it will flip to the other side. If it's in the top, it'll go to the bottom. If it's in the bottom, it'll go to the top. I like it. Somebody keeps giving me, is that a thumbs up again? Or is it a clap? I love it. Okay. So, one thing that can happen to us in section 6-7 is something like this. A lot of people get very, very confused on this, and just I want you to tell me, what are the only parts of that problem that want to flip, that want to move?
The negative.
Yeah, the negative powers. So those 2 A's and those 5 B's are cool where they are. These 2 don't like it. Negative is negative. So if you took these 3 A's up and you took those 8 b's down, they will become positive because the negative will have done its job. So those 2 a's are still there. Those 3 a's come up. Those 5 b's are down there, and those 8 b's come down. So whatever has a negative power will flip. And then that's not hard, right? How many a's will I end up with on the top? What do I do up here?
Add them.
Yeah. So it'll be a5, a to the 5th over b to the
13.
coolness. All right. And then the last thing I want to talk about real quick, it's actually something on the quiz that just came back to my head. Somebody help me out. We'll get into that next time. Let me come back just for a second about something that was on the quiz that drove me a little bit crazy. What's x squared times x to the 7th? Nothing major here, nothing amazing.
X9.
X to the 9th, yeah. Did the x change?
No.
Because I got 2 x's, 7 x's, so of course I still have 9 x's. I can't have 9 w's now all of a sudden.
Yes. Yes.
So what is 5 squared times 5 to the 7th?
That's 8. 4 hours, 5. Okay.
It's not,
25.
nope, there's no 25s. What do I have
Okay.
here? What does this mean? I got 2 5s times.
I got it. It's the same. You mean the same? 5, 9. Okay.
Yes. If you write this, I'm like, how the hell did you get 9 25s? And it only had a couple 5s and a couple and 7.
5, 9.
No way in hell. So powers mean that multiplication hasn't happened yet. This would suck, right? If I said figure out what 5 to the 7th is by hand, you multiply 5 times 5 times 5 times 5 times 5. And I'm not done yet, right? You have to do it 7 times. Holy shit. So those multiplications haven't happened yet. So if I have 2 5s that I got to multiply, and then I got 7 more 5s I got to multiply, of course I got 9 5s that I have to multiply. I don't multiply because that's the whole point. I'm not multiplying anything yet. I'm just keeping track of how many of them I've got to multiply. That's what powers do. So it's sort of like if I add 2 5s plus 7, that might be too weird. I'm not going to go there. I'm kind of pushing the analogy a bit. Hopefully that makes sense. The base doesn't change when you're collecting powers. The base can't change because all of a sudden you have that many of something else. That doesn't make any sense. I know right now somebody out there is like, none of this makes sense, Jeff. Okay, I think that's enough. So next Wednesday, oh, sorry.
Stop.
What's up?
I just stopped.
Okay.
I just stopped. My brain broken.
Oh, okay. So we better stop now. On next Wednesday is going to be.
I'm joking with you.
I'm with you. Next Wednesday, it's the quiz that's on 6, 5, 6, 6, 6, 7. Right? Next Wednesday. And together with that quiz we just had, it was what test 2 would have been. We'll talk more on Monday about plans for like review quizzes that go to stuff that was from before. I'm not going to just throw them at you out of nowhere. Not quite, Youngsha. We just barely got into 6, 7. We're not quite done with the whole chapter 6 yet. So we're going to finish it up on Monday. Okay. Anybody, any questions? If not, you can.
No, thank you. Bye-bye.
Bye. All right. The rest of you guys, if you are here, we'll see. How would we know which question we got wrong in our quiz? Alani, are you still there? Yes. Let me see. Oh, did you? No, that wasn't you. You didn't turn it into me by email. Did you turn it in on Canvas?
I turned it in on on Canvas.
On Canvas. Okay, let me look you up real quick here. All right, there you are. Yeah, you should be able to see the markings when you log into Canvas. You should be able to look at this and see the markings. I've written on it in green.
Oh, okay, no problem then. I
Okay.
haven't checked. I know last time I couldn't see it, so this time I'll just check then.
Okay, let me know.
Okay, thank you.
Okay.
All right, bye.
Bye, everybody. Whoever's really there.